Hello, my name is Derek from Tomcat Gas Training and welcome to this video all about these. So in this video what we're going to do is we're going to look at gas meters. We're going to look at all the different types of meters. We're going to look at how to install the meters, and we're also going to look at how to size a gas meter. So as usual at Tomcat Gas Training videos, let's just get on with it. So the first thing we're going to do is we're going to look at the different types of meters. So while we're here, we might as well look at this one. Now this one is a G4 gas meter. So it gives us 6 meters cubed an hour or 212 cubic feet an hour. So that's the output this meter can deliver. So let's have a look at another one. This is a U6 gas meter. This also gives 6 meters cubed an hour or 212 cubic feet an hour. But unlike the G4 which we've just seen, where that test dial is in meters cubed, the test dial for this one is in cubic foot. Now this is an E6 gas meter. So it does deliver 6 meters cubed an hour or 212 cubic feet like the G4 and the U6. But the actual amount of gas inside there is half the gas of a G4 or a U6. This one is a G10 gas meter, which gives you 16 meters cubed an hour or 265 cubic feet. So this is the biggest gas meter a domestic gas engineer can work on. We've also got 35mm pipe connected to this, which is also the biggest pipe a gas engineer can work on, to a maximum volume of 0.035 cubic feet. So that's a look at the domestic meters a gas engineer will work on. The only other one I'm missing is the U16, which is the same meter as this, but it has the test dial rather than the numbers. So that's looking at the meters. Let's talk about installing the meters. Now, before we install a meter, there are some considerations we need to look at before we just go ahead and install this meter. So there are 9 main ones we need to look at. So the first one, the meter must be secure and not move. So before a gas meter goes in, you must take into considerations whether that gas meter can be moved or not. The connections are not strained. So whether it's the inlet to the meter or the outlet, it cannot be under any strain. Number 3, the meter does not compromise a fire escape route. So I don't think you would be installing a gas meter on a flight of stairs, would you? The meter is not to be fitted in a corrosive atmosphere. So that could be bathrooms, shower rooms, under kitchen sinks, outside. So we'll look at the ways you can install a meter outside shortly. So, not to be fitted where food is stored, because again, food can be affected by gas and the food can also affect the meter. You mustn't install a meter where it could cause an obstruction. So in the middle of the living room, don't want to be putting it there, do we? Like we say, you cannot install them under a kitchen sink for this corrosive atmosphere, because you will be putting your cleaning chemicals under that kitchen sink, or most people put the cleaning chemicals under a kitchen sink. In proximity to electrical wiring or switch gear. So a gas meter or a gas pipe needs to be 25mm away from electric cable or 150mm away from a consumer unit. So they're the considerations you need to look at as well. And finally, under stairs, if the stairway forms the only escape route in a house with more than 2 floors. Now there are some exceptions for that. You can actually put a gas meter in a fireproof box, or you can actually put the outlet on a temperature sensor which will shut the gas off. So there are ways of doing that, but all gas meters now in new builds are put outside. But if you are having a loft extension and your gas meter is under the stairs, that gas meter is probably going to need to be moved. So these are the considerations we need to do before we actually go ahead and install a meter, if you was going to install one. Okay, you would require MET 1 if you were going to put a secondary meter in, and if you are putting a secondary meter in, you need to comply to all this. So let's just get over here now and look at this gas meter, and let's go through the things we need to be looking at when we're doing a visual inspection before we do any work on the gas supply. So let's go and have a look at that now. So let's closely look at installing these gas meters and the considerations we need to do when we're checking meters or when we're installing them. Now this all comes under British Standard 6400. And it's in 3 parts. So part 1 covers low pressure up to 75 millibars. Part 2 is medium pressure, 75 millibars to 2 bar. And part 3 is LPG meters. So that's what the British Standard 6400 is. So first of all, ECV, or should we say emergency control valve. Now the emergency control valve isolates the gas supply coming from the inlet pressure to the actual installation. So we could have in medium pressure up to 2 bar coming in here, but it will be a different regulator. But we're on low pressure, so we've got 75 millibars or up to 75 millibars coming into the regulator. So this ECV is very important. First of all, can we get at it? Can the customer turn it off? They're the first considerations we need to do. So if this is unaccessible in a non-emergency situation, that would be deemed as at risk in our unsafe situations procedure, IGMG 11. But if it's in an emergency situation, then it would be ID. So needs to falter off and not falter on. This one falls to on, but it is a trading centre. But that's the main things about the ECV. Can we get at it? Okay, then we do some tests on it, which we'll look at later. The ECV also requires this label to tell the customer how to turn the gas on and off, which is attached, as you can see, to the Anaconda. This coming from the ECV is now what's called the pliable connection, or commonly known as the Anaconda, and it's made of stainless steel and it cannot be stretched. So when we're doing the visuals on the gas meter, we need to have a look at this and make sure it's in good condition. We have a lot of problems with Anacondas leaking because gas engineers like to put flux all over them and it rots them very, very quickly. So if you are soldering over the top of an Anaconda, make sure you protect it from your flux, because your flux will go straight through it. Next we've got the regulator. Now the regulator needs to have a seal on it. Okay, and this shows that it hasn't been tampered with. So on your visuals, make sure there's a seal and make sure there's no signs of corrosion. Now a gas meter also needs to be secured. It needs a bracket, and the bracket should keep it off the floor and keep it off the wall. So the reason why you keep it off the floor is stop vibration and corrosion coming from bottom, and the reason why we keep it off the wall because we don't want it coming in contact with cement. But its main purpose is to stop the customer stealing gas. So it's very important that this bracket is secure, and there are seals here, tamper seals. Now these tamper seals have got shear bolts on them and the shear bolts haven't been sheared. You just keep tightening until they come off. So we need to make sure that these tamper seals are still there, so again the customer cannot disconnect this and steal the gas. Now you notice on this installation we've only got one flexible inlet. So that's basically what you're allowed, one flexible connection. But if you've got a flexible connection on the outlet, that's technically not allowed. But if you have secured the gas pipe within 600 mil of the flexible connection to the wall and it is secure with a bracket, then you just do basically a risk assessment to see whether you think the customer is stealing the gas. And then we've got the meter itself. Now the meter itself shouldn't have any signs of damage or corrosion. So if you've got signs of damage or corrosion in our unsafe situations procedure, that would be at risk, and then obviously if it was leaking gas it would be immediately dangerous. And then the last thing we need to make sure we've got is earth bonding. There's no earth bonding on this, but the earth bonding should be within 600 of the meter if the meter is installed internally, and should be 10mm cross-sectional area and be a radial circuit going back to the consumer unit. We'll have a look at the earth bonding a little bit more closely soon. So the last requirement for this gas meter is this label here. So in the event of a gas escape, or if you can think you can smell gas, it then gives the customer the emergency contact number of 0800 111 999 to contact. So that's the last thing on the meter, is the labels. So these are the considerations we need to have when we first visually inspect a gas meter. Now, traditionally, gas meters have always been installed inside. The reason for that mainly was because they need a nice dry, warm location to stop them corroding. So inside the house has always been kind of a perfect location. But nowadays gas utility companies want to read the gas meter on a regular basis, so they've either do that with a smart meter, or they come out to the house and want to gain access to reading the meter. So the easier way of doing that, so they don't have to gain access to the property, is the meter being installed externally. So let's have a look now at the ways a gas meter can actually be installed outside. So the ways we can install a gas meter outside is by using one of these, a gas meter box. So this is what the gas installation and use regulation says about meter housings. So 13 paragraph 1, where a meter is housed in a meter box or meter compound attached or built into an external face or the outside wall of any premises, the meter box or meter compound shall be so constructed and installed that any gas escaping within the box or the compound cannot enter the premises or the cavity in the wall, but must disperse to the external air. So this is why we need to make sure that everything is sealed within the meter box. Paragraph 2. No person shall knowingly store readily combustible materials in a meter box or a meter compound. So that's very important. Seeing loads of people using them as store cupboards. Paragraph 3 says, no person shall install a meter in a meter box provided with a lock unless the consumer has been provided with a suitably labelled key for that lock. And also, if you look at number 4, no person shall install a meter within a meter compound which is capable of being secured unless the consumer has been provided with a suitably labelled key for that compound. So this is very important if you've got block of flats or masonettes. They must have 24-hour access to the meter ECV. Now if they haven't got 24-hour access to the ECV, then they must be provided with an AECV, or an alternative emergency control valve, within the flat with a test point. So No key and no 24-hour access, and no AECV, that would be classed as at risk. But if they do have the AECV, that's fine. But if they don't have the AECV and do have 24-hour access to the main ECV, then that's not to current standards. Gas meter boxes have to be extremely strong, weatherproof and highly durable. They are available in various fits such as recessed, surface mounted and semi-buried. These protective housing units are ideal for both new build installations as well as the replacement of older and damaged enclosures. The glass, reinforced plastic or GRP construction of these items makes them extremely hard wearing and weather resistant. The gas meter boxes are designed and tested for installations to the British standard BS 8499-2009. If the gas meter box is damaged or missing, or even the doors missing, then this will be categorised as at risk in our unsafe situations procedure IGM G11. Now, as you can see, this is a surface mounted meter box. Now, every gas engineer should be carrying one of these. Can't do your job without one of these. And this is just basically a meter housing or a meter box key. And this allows you to open the door. Simple as that. Now, you can see now I've opened the door. This is quite restrictive for a gas engineer to try and work in this meter box. Okay, but there is a little trick for this type of meter box. Now, for the meter box which are inside the wall, the recessed ones, they're dead easy to work on because they give you a big area to work in. You don't need to worry about the box being in the way. The ones in the floor, the semi-buried ones, again, the box lifts up. There's loads of room to work on them. But for these surface mounted boxes, there isn't. But basically, not all of them, but some of the boxes, they just have 3 plastic studs, for the want of a better word. There's 2 studs in the top and 1 in the bottom. So you can just remove the studs, take them out. I've already removed them out of this meter, and it just comes out. So you can now see we've got full access to the meter, the regulator, we can do the pipe work. This is the knockout where you could knock that out and take the pipe through the wall. Remember, if this was medium pressure you wouldn't be allowed to do that, but if it's low pressure you could actually take it. Once it's sleeved you get a special sleeve for that. I'll show you that in a minute. And it goes right the way through the meter box and it gives you full access to work on the meter. Even doing a tightness test, it makes it so much easier to remove the front housing. Just be careful though guys, if you break these housings you've at risk the situation. So be very careful if you do want to remove them. But the ones with the little flaps at the front, nightmare. Try and remove them. But be word of warning, be very, very careful. Now, this is one of the sleeves which goes through this hole here. So this comes with the meter box. So you can actually see it's slightly tapered. Okay, so what you'd have to do is mark where it's going to go, core through your hole, slide this through, and you can see it's not that long. So this would be where your pipe slides through. Okay, and it would have to be completely sealed. Now again, yes, a lot of electricians take their earth cable through there as well because there is plenty of room, you can see. But obviously if it was medium pressure they ain't doing that. Okay, and it's not good practice for them to do it, but as long as it's sealed here at the front here, we're allowed to do that. And the thing we seal it with is this stuff. This is our flue jointing compound, which is non-setting and flame retardant putty. So this is what every gas engineer should be carrying, a tub of this, and it's just like sticky Play-Doh. Okay, so you don't use plumber's mate for sealing around there, you use this stuff. So what you do is once your pipe's through there, you then just get this stuff and then you completely fill the big hole. whether there's an earth cable going through there or whether there's not, you need to seal it. And obviously if you're not using this, because you're not going through the box, you don't cut the hole out. Okay, just knocks out. You don't do that. There is one at the bottom of the box where you do it there. Okay, so that's how we seal a meter box using the right stuff, which is called flue jointing compound, which is a non-setting flame retardant putty. Not silicone and definitely not plumber's mate. So this is our semi-buried meter box. So you can actually see it is buried in the ground. And if we do open this box, you can actually see, like I've just said, there is loads of room to work, like the one where we've just had to remove the cover. So dead easy to replace the meter or the regulator here. But you can also see there is a flexible connection on the outlet. Now this is the only meter, technically, where you can have two flexible connections. One on the inlet and one on the outlet. Now loads of different designs on this meter box, and you should always follow the manufacturer's instructions. It also depends on the meter type as well, depending on how you get into and out of the meter. Like I say, just follow the manufacturer's instructions. Now, one of the major things the gas meter does is gives us our permissible drops when we're carrying out a tightness test. Now, the meter being connected to the pipework and no appliances being connected, and it's a new installation or an old installation, we would have a 0 drop. But if we've got old pipework, old appliances with no smell of gas, we are allowed a permissible drop depending on the size of this pipe. So, if we have pipework equal to or less than 28 millimeters attached to this gas meter, if it was an E6 gas meter, we're allowed an 8 millibar drop with appliances connected and no smell of gas. If we've got a U6 or a G4, it would be 4 millibars. Again, appliances connected, no smell of gas. If we've got a U16 or a G10, it would be 1 millibar. Yeah, you guessed it, as long as we've got appliances connected and there's no smell of gas. If there was no appliances, it would be 0 drop. Now, if our pipework is greater than 28 but equal to and less than 35, if it was the E6 meter, we've dropped down now to 4 millibars. Remember, appliances connected, no smell of gas. If it was a U6 or a G4, we're allowed 2.5 millibars. And if it's a U16 G10, 1 millibar and no smell of gas with appliances connected. So that's our permissible drops on tightness tests when we've got the meter connected. So let's talk about something else about meters then. So, as discussed previously, let's have a look at this protective equal potential bonding. So the gas installation pipework will be required to be protected by this equal potential bonding, and this will need to be fitted by a competent electrician. Now there are qualifications for a gas engineer to now do this earth bonding, so it's a separate standalone qualification and it just allows you to do earth bonding. So the connection to the pipework will normally be fitted within 600 of the gas meter or before the first branch or T. So this is to ensure that the protective equal potential bonding connection is readily visible during our inspection. However, if the meter is external, then the regulations state that the bonding must be as close as practicable where it enters the building. And we're going to have a look at this through this technical bulletin 102, or you can find all this information in BS 7671 or the electrical regulations. So let's have a look at this technical bulletin 102. So the first drawing we come across is the low pressure fed surface mounted domestic meter box. So you can see we've got two connections here. We've got this one, which is the preferred
connection as it comes into the property, but it does show the earth bonding going through the sleeve, and it says it's the non-preferred position. Okay, but it can actually come through the bottom of the meter box and connect onto there. So if the electricians are connecting it, they shouldn't be going through the sleeve. They should be bringing it externally through the bottom of the meter box and connecting onto the pipe there. But this is our preferred method. So you can now see this from this drawing where it shows the earth bonding coming up and through the bottom of the meter box. Or you can actually bring it through the sleeve, where the preferred location is here, rather than up in the meter box. So this is what we should be looking at for low pressure installations. For medium pressure installations, we definitely do not want the earth bonding coming through the back of the meter box. It has to come up through the bottom of the meter box for medium pressure. Now, if you did have an earth cable going through the back of the box on a medium pressure, then you could be at risk in this because it's damaged the integrity of the box. The preferred location will always be inside the building, but if you can't get it inside the meter box, it must follow the pipework, because in a medium pressure installation, the pipework cannot go through the back of the meter box. And again, if it did go through the back of the meter box, that would be at risk. So make sure this earth bonding and medium pressure does not go out through the back of the box. And again, in the semi-concealed meter boxes, which are kind of buried in the ground, we need to be making our earth connection preferred location actually inside the property. But again, we can follow the sleeve going out through the wall and then into the outlet on the gas pipe. So that's a look at the Technical Bulletin 102 and where our preferred locations are for this earth bonding.
Now let's sum up. So if you come to a gas meter without earth bonding, what you'll need to do is you'll need to tell the responsible person, or issue one of these stickers or a label to tell the responsible person that the gas meter will require earth bonding and the earth bonding needs to be installed by a qualified electrician. So that's earth bonding. Now, there are situations where you may come across this here instead of copper pipe. This is lead pipe. So, before we talk about this, let's find out exactly what the gas regulation says about lead pipes.
So, Section 5, Paragraph 2.1 of the Gas Safety Installation and Use Regulation says, no person shall install in a building any pipe or pipe fittings to use or supply of gas which is made of lead or lead alloy or made of non-metallic substances unless the pipe is connected to a ready movable gas appliance designed for use without a flue, so a cooker hose. So that's what's basically they're saying for lead and lead alloy pipe, that a brand new installation is not allowed now to have lead pipe or lead alloy in it.
So basically, as you can see, if you come across this attached to a gas meter and you're only doing servicing or you're just doing landlord's reports, then you don't really need to be replacing this. Now, the inside diameter of this lead pipe is about 18 millimeters on this lead. Now, there are some which are a lot thicker on the outside but a lot thinner on the inside, and technically it might not be good enough if you're installing a new condensing boiler, because the inside diameter for a 22mm copper pipe is about 19 millimeters. 1 millimeter make any difference? But it does if this is a lot thicker on the outside. So basically, if you are installing a brand new boiler, a new condensing boiler, you're going to need to be replacing this lead pipe, because it possibly won't give you the amount of gas you require for the appliance to work safely. Now, this is what we used to be able to do with lead pipes. We could join copper pipes to it, and that was called wiping a joint. But now you can actually buy lead locks, so special fittings designed to join copper and lead together. This is illegal on gas. So this is a more common sight you're going to see with lead connected to a gas supply, where they're using a flexible lead connector to connect onto the copper pipe. I would be actually removing this every time I installed a new appliance, because it's not to the current standards. And finally, with the lead, one of the things you don't do is actually connect the earth bonding to the lead, because the lead will oxidize and will stop the earth bonding working. So if you do come across this in this situation, then move the earth bonding to the copper pipe, or just replace the lead. Always try and think of, in every circumstances, replacing the lead, but the regulations say if it's an existing installation on the lead pipe and the lead isn't leaking and it's not affecting the safe operation of any of the appliances, and technically you can leave it alone, but I don't think I will.
Now, you might recognise this drawing from when we did the pipe sizing, so if you haven't seen our video on pipe sizing, why not? Anyway, so get over a look at the pipe sizing video, but you can see when we did the pipe sizing, we had a G4 meter, which gives us 6 meters cubed an hour, but our total load for all the for the boiler, the cooker, the 2 fires, comes to 6.65 meters cubed an hour, but this gas meter can only give us 6 meters cubed an hour. So what we're going to do now is we're going to take a look at how we're going to size a gas meter and see whether this meter is allowed on this installation or not. So let's get on with that. Now, sizing a gas meter is pretty straightforward. There's only 3 steps to do. So the first one we need to do is determine the heat input rating of each individual appliance in kilowatts and apply the relevant diversity factor. So this is a chart showing our diversity factors. So first we've got a central heating appliance, not combi boilers. So we would do it by 1. If it's a unit heater, we would do it by 1. And if it's a circulator, we would do it by 1. If we've got a combi boiler, we do it by 0.8, instantaneous water heater, 0.8, sink water heaters, 0.6, room heaters, 0.6, tumble dryers, 0.6, hot plates, 0.6, ovens, 0.6, but cookers, we do 0.4. Never really get that, but there you go. And refrigerators, because it's basically a pilot light, we do it by 0. So what we mean is we take the boiler from our pipe sizing exercise, which was 30 kilowatts, we times that by the diversity factor, which was 1, so it comes out at 30 kilowatts. We take our cooker, our range cooker, which was 24 kilowatts on our pipe sizing exercise, so cooker 0.4, we times it by the diversity factor, gives us 9.6 kilowatts. Our inset live fuel effect fire, 6 kilowatts, so 6 times 0.6 gives us 3.6, and our DFE, again, because it is a room heater, time it by 0.6, so 10 times 0.6 is 6 kilowatts. So if we add those together, it gives us a diversity factor of 49.2 kilowatts. Now, what we've got to do in step 2 is add up the total gas load requirements for all the appliances, and then we need to convert the total kilowatt figure into megajoules. So this is what we've got here. This is our total load, which was 49.2 kilowatts. So we need to do 49.2, and then we need to times it by 3.6, And the reason why we times it by 3.6 is there are 3.6 megajoules in a kilowatt, which 49.2 times 3.6 is 177.12 megajoules. Now, part 3, it says, divide the total number of megajoules by the calorific value of natural gas. And at the moment, our calorific value of natural gas is 38.76. So this will determine the equivalent gas flow rate in meters cubed an hour, and will ultimately determine the size of the meter we're going to require. So if we take our 177.12 megajoules and we divide by 38.76, it gives us 4.56 meters cubed an hour. So we're less than 6 meters cubed an hour, so you can see our meter was correct. So we can either pick a U6, E6 or a G4 gas meter. Now, a lot of you guys are always out there looking for a cheat, because that's how you like to roll. So if you do want to cheat, we can do 38.76 divided by 3.6 gives us a figure of 10.76. So instead of doing this calculation here, if we take our 49.2, divide it by 10.76, it gives us 4.57 meters cubed an hour. It's just slightly different than that one, but there you go. Who's going to argue over 0.01? And then we can still get a U6, E6 or a G4 gas meter. So that's how easy it is to size a gas meter, but you will need our good old diversity factor chart to be able to do this.
And that is the end of this video on gas meters. So as usual, if you've liked this video, why don't you give us a thumbs up or leave a constructive comment down below. If you've not subscribed to our channel, then please subscribe because it helps. And don't forget to hit that notification bell, because YouTube will tell you when we release a new video, which is mainly on Mondays and Wednesdays. All I've got left to say is, thanks for listening, thanks for watching, and I'll catch you on the next one, guys. Cheers.